Good evening, all.
Good evening, sir.
So first you tell me what is meaning of owl?
Sir, first, it's the normal usage of aval.
Normal
Aval, which means
Yeah.
first. Yes.
means what is meaning?
Aval number. Have you never heard of the saying?
No.
Aval. It means first.
Okay. So from childhood you are named first. Okay.
Everyone says that when they know my.
I pray it should continue.
Thank you, sir.
And you ask her, what is her name? Hello, Muskan.
Hello, good evening, sir.
Good evening. So I was asking, what is the meaning of Muskan? You know what is the abal? Abal, you know what is the word?
Right, it means smile.
Muskan, do you know?
What? Hello?
Abal means?
No, I don't know.
It is number one. Abal is number one.
Okay, yeah. Oh.
Okay. Just now he clarified actually. I was also not knowing. And what is your name?
Namaskaram. It means smile.
Very good. Mine is Chanchal. Always restless. So today we'll be starting our discussion with who will start. I think Aval should start today.
Okay, so you asked me to explain about the relativity, right? To you.
Yes.
Yes. So I need to write somewhere. So how can I do that on meeting?
I think you have option for screen share, and there I think there is option for writing also.
Okay, so let me just
You
see.
explore 1-2 minutes, no issue.
Okay.
First you share the screen.
Right.
This
Just
option is there.
so what I'll be explaining to you right now, we'll include that as our content for the understanding, for the making of posters.
Yes.
Okay.
Today I
Where
have sent 2-3 samples of poster about
yes, I saw them.
Yes.
I wasn't sure about what to do with them. Like, so are these?
Yeah, I just sent a sample, and we will use a mind tree mind map.
Okay.
Mind map was one option in latex. Where mind map, where you can, yes, this is the thing. I think you can write here.
Is this visible? What
Yeah,
I'm.
it is visible. It is nice. I have never used it till date.
Okay, this is just the normal whiteboard. I haven't used it much either. So I'm just using it for the second time, I think.
Okay.
Right. So
Is not knowing what we are going to do.
okay. So right. So sir asked me to explain about the special theory of relativity. So which I have some knowledge about. So I decided to give it a shot. So the thing is, when we were about to make the posters, I was planning to do this after we had covered electrodynamics and mechanics because there is a little bit of knowledge, just facts, no mathematical stuff needed from those topics. So, but without knowing them also, I mean, I can introduce them to you. So, but if we were doing this formally for the making of the posters, I would prefer if we did this at the after the covering of 11th and 12th syllabus. So, is that fine, sir?
Yeah, it's fine. Yeah, no issue.
Right. So, okay, I'll start. Ignore my writing because I'm using a trackpad. I don't have a mouse. So, wait, I hope my writing isn't too bad.
It is not like that. When we write, it will be like this only. But why you would use this Excel or Word something, or you can type also if you don't require any pen.
No, I need to make diagrams, right? So I won't be able to do
Diagram
that.
also you can draw in pen, PowerPoint or any other places, no?
All right. So I didn't have time actually to make a PowerPoint presentation because I
No,
just
not
got in.
PowerPoint presentation. You open a slide and there you can type. What I am saying. It will
Right. No,
save lot.
the typing part isn't a problem. It's just the
Okay.
diagram making
Okay.
part.
Yeah, then you go ahead. Yes.
Right. So
Because this is very tedious. I have used
yes,
some time.
yes.
You
So
can either like write in a doc and like make diagrams here, like if that works.
right, that'll be better. Right. I'll just do that.
So one thing.
Right. So is my document visible or just the whiteboard?
Right now it's the whiteboard only.
Just give me a second.
I think it's coming up.
I think I've only shared the app, not the whole screen. Wait.
What I do, wait, first let me share my screen, okay?
Okay. Go back. Right. So should I stop sharing?
I
Right.
think
Right. Your is visible.
So now your mail ID.
Yes, sir. It is Aval ABBAL 280. Yes, that.
What about Muskan?
Muskan, Muskan. Yeah, second one, sir. Second one. Muskan Himmat. Yes.
So I think you require permission to use this. You now check your mail.
Right. Yes. Okay, right. So we can
So
also
now
edit this.
you can share it and you can use this. So it will be a common platform where it will be saved automatically and we can access whenever we require this.
Right. So should I write here only or on my own personal laptop?
You can start here.
Right. Okay. So I'll share my screen again. Should I share my screen, sir, now?
Yeah. Now you stop. Now you can stop.
I'll just share the whole screen. So is it visible?
Yes. Nice.
Right. So I'll start.
You can put a date first and then you can. Yeah.
What's the date today? 30th of
30th September. And whatever we want to share, you can write it down. So anytime we are free, we can open and see it. Okay?
Yes.
Last time we had 9 interns, and we are using a single doc for maintaining the activities.
Okay.
This is good. Now it is documented also.
Right. So should I start?
Yes.
Okay. So when we're used to thinking about physics, what we're most familiar with, the things we called common sense, are of classical mechanics. So I'm sure you both know about classical mechanics, right? Classical physics, I mean, the Newtonian mechanics and electrodynamics, the stuff we study in 11th and 12th. So, right. So can you just tell me if you know what classical physics are?
Actually, honestly speaking, we don't have a clear-cut definition sort of thing.
Right.
We
We
know,
don't have a clear-cut definition of classical physics as compared to modern physics.
you define it from your angle, and
Right.
let us interact with that.
Right.
That will be fine, because something already you have in your mind.
Right. So we'll just see two common sense theories that we all accept to be true, uh, true in general. First of these is
It is faster, no?
yes, it's definitely faster. The first of these is Newtonian mechanics. So I'm sure you all know about Newton's laws of motion and the mechanics part, the F is equal to ma, v is equal to u plus at stuff, right?
Yes.
Right. That is covered in Newtonian mechanics. And
Okay.
the second of these is Maxwell's laws of electromagnetism. So
Maxwell's laws also we are not clear. Simple, honestly
okay,
speaking.
like so we don't need to know about the Maxwell's law.
No, okay. If you can tell roughly, we can
Right,
then
right,
go
right,
into depth
right.
later.
So Maxwell's laws are just the four most fundamental laws of classical electromagnetism. They are all related to electric and magnetic fields. So we just have four laws, and these four are the four most fundamental laws of classical electromagnetism. Everything else in classical electromagnetism, Coulomb's law, Ampere's, the forces on magnetic wires, whatever we study in class 12, F is equal to BIL, F is equal to QVB, everything can be derived from these four laws of Maxwell. Okay, so these are, in a sense, the most fundamental laws of classical electromagnetism, and using them, we can derive almost all of classical electromagnetism. Almost all.
Okay.
Just one extra, if we just use one extra fact, which is the Lorentz force, combining that with Maxwell's laws, we can derive all of classical electromagnetism.
Okay.
Okay,
Okay.
so these two were very very well established,
Okay.
experimentally verified theories for hundreds of years. Okay, and so everyone believed in them, everyone took them to be true, and no one had any doubt on either of these. Everyone was sure that Newtonian mechanics is correct, everyone was sure was Maxwell's laws are also correct. Okay, because
Okay.
Newtonian mechanics are mostly common sense and intuitive, pardon the typos, and intuitive, and Maxwell's laws were mathematically rigorous. So Maxwell's laws were not really that intuitive, because we have a sense of how objects move, but we don't have that much intuition about uh, electric fields and magnetic fields, right? I'm sure you both can agree with me on this topic. That mechanics is much more intuitive than electrodynamics is, especially that electric field and magnetic field and electromagnetic wave stuff, that is less intuitive than balls and gravity are. Right. So everyone took Newton mechanics to be correct because it was so common sense, and everyone took Maxwell's law to be correct because they were mathematically rigorous.
Okay.
Now, but actually turns out that these two supposedly well established theories are not uh, compatible with each other, right? So if you just take Newtonian mechanics by itself and you don't consider any electromagnetic stuff, Newtonian mechanics makes sense by itself. And if you just consider the laws of electromagnetism, you don't consider mechanics, then the magnetism also makes sense by itself. But if you consider both mechanics and electromagnetism to be true at the same time, you find that these two theories are not really compatible with each other and they lead to contradictions. Okay. And I'll just give you an example of one of those contradictions, what one of these contradictions are. Okay, so for that I need to draw.
Okay.
Right. So consider you have a person A over here, and you also have a person B over here, and you have some sort of light source. Okay. So so before wait. Right, I shouldn't go into this right now. I have to tell two more facts first.
Okay.
Sorry for that. I just missed one step.
No. Okay.
Facts. I haven't rehearsed this before, and that's why. So, two more facts. The first, this comes from Newtonian mechanics. Lengths and times change with frame of reference. So, do you know what frame of reference is? A frame of reference.
Frame of reference can be, suppose if I'm doing in 2D, then XY can be x-axis, y-axis can be frame of reference.
Right. And for example, if you're just moving in a car, then you can have your frame of reference, and a person standing on the road can have their frame of reference, and both can be moving with respect to each other depending on what frame you choose. Right. For example, if you're traveling in a car, then you are stationary with respect to yourself, but you're moving with respect to someone on the road. And with respect to you, the person on the road is actually moving, right? So we're all clear with that, right?
So whatever you are discussing, no, this thing actually I can model without much difficulty programming in Excel.
Okay, right. That will be nice.
This theory, when you this theory and you explain how to do it, we can do it model means and animate. Yes. And
the only
frame
thing
of reference also will become easier to understand then.
Right. The only thing is that I was planning that this topic would be covered after mechanics and after electromagnetism also. So by that time, the people studying this would have knowledge about both frames of reference and both about Maxwell's law.
Yes. That will be taking up in some other posters, and
right.
So poster number 1, 2, 3. So it can appear in fourth and fifth, like that something.
Sure.
But we should first get clarity on that.
Right. Okay. So for now, I'll just tell you. So I think frames of reference are not that hard of a topic to understand. I think both of you have sufficient intuition about that. Am I right?
Yes.
And so one thing that we all believe to be true is lengths and times don't change with frame of reference. So for example, if you are a person standing on the road and a car started traveling at 12 p.m. say, all right, at 12 p.m. a car started moving, and after 1 hour, the car moved for 1 hour, all right. So the person standing on the road will see that the car moved from 12 p.m. to 1 p.m. Okay. And now we also believe that a person sitting inside the car will also believe that the car started moving at 12 p.m. and moved till 1 p.m. Both of them will say that 1 hour has passed. Is that common sense? Like that's what common sense tells us, right?
No, we cannot follow actually. I am seeing, I am moving in car. I am seeing a person standing.
No. The person standing on the road and the person sitting in the car are different. They don't know. They are not interacting in any way. So the car starts moving at 12 p.m. for the person standing on the road, and the car moves for 1 hour. So when the car stops, the person standing on the road will say that it is now 1 p.m.
Yes.
Right. There's no doubt about that.
No.
Right. And we also believe that the person sitting in the car will say that the car started at 12 p.m. and it moved till 1 p.m. Right. So this is what common sense tells us, right?
Yes.
And also about lengths. So let's say you have a ruler of length 1 meter, 1 meter ruler you have, and suddenly that ruler starts moving with respect to you. Okay, it starts moving any in any direction, right?
Okay.
So we'll believe that the ruler is still of length 1 meter, right? So these things are taken for granted. I'll just make this bold because this is really important. Are taken for granted in classical mechanics. If you really think about it, these things aren't mathematically proven. We just take them for granted because they are intuitively they make sense, right?
This is you are talking something about when we start mathematics. No, that we start with that Euclid's lemma or sort of thing, something we take granted. This and we start.
Right. We take these to be axioms in classical
Yeah.
mechanics. Right.
Yes. Yes.
In a sense, we take these to be axioms that lengths don't change and times don't change when you change frames of reference. Okay.
Okay.
So does that make sense, or should I repeat?
That actually we'll do. Time permits, we'll model it and we'll see what we are explaining, whether we can model it or not. And after creating a model, we will get a real sense, means feel of that situation, what you are trying to explain.
Right. Okay. Okay. And the second fact that I want to tell you is this comes from Maxwell's laws.
Okay.
Speed of light in vacuum is c, which is 3 into 10 raised to power 8 meters per second. Okay, so this is derived straight from the four uh, laws of Maxwell. Okay, using the four laws of Maxwell, you can derive this. You can actually mathematically derive this. That the speed of light in vacuum is 3 into 10 raised to power 8 meters per second. Okay.
Okay. So you mean to say that this formula, this speed of light, we have calculated from here?
From the Maxwell's laws of equation, laws of electromagnetism.
Okay. So when Maxwell's law were not there, then we were not knowing the velocity of light.
No, we were knowing the velocity of light, but using this, when we calculate the speed of electromagnetic waves in vacuum, we came to know that it actually equal to the velocity of light, and from there we conclude that light is actually an electromagnet.
Before
Right?
that, there was no proof.
Before that, we were knowing it experimentally, as far as
Okay.
my knowledge goes.
Okay.
We were knowing it experimentally, right? But the thing is, the speed of light can be straightforwardly derived from the four laws of Maxwell.
Okay.
Okay, and this derivation does not depend on the frame of reference. Okay, and this derivation does not depend on the frame of reference because the four laws of Maxwell they do not depend on the frame of reference.
Yeah.
Okay, they just depend on the.
I can to some extent I can correlate now.
Okay. Okay. They just depend on the medium. They don't depend on the frame of reference. Okay. The medium can be vacuum, it can be air, it can be ice, it can be anything.
In the sense, now to some extent, can we think that frame of reference is something position?
Yes. I won't say position. I would say velocity.
Okay, velocity, whatever way you can explain again, velocity is position, change of position comes.
Right.
Okay.
So, and this derivation does not depend on the frame of reference.
Okay.
So as it does not.
Is it very important point you are stressing on that frame of reference?
Yes, this is a very important point that this derivation does not depend on the frame of reference. This is actually a key point.
Okay.
As it does not depend on the frame of reference, we can conclude that the speed of light is same in all frames of reference. Inertia. So, do you all know what inertial frames of reference are?
Yes.
Inertial frames of reference are which they move with constant velocity, right?
Mm.
They're not accelerated. So, wait, on the inertial, I should have added inertial here. If you add acceleration, then weird stuff happens because you have to consider pseudo forces and other stuff, right? This derivation does not depend on the inertial frame of reference. Okay, so are you both with me up to this point?
Yes.
Yes.
Right.
Not fully, but
Right. I can understand because I haven't explained Maxwell's law and this derivation. I haven't done this derivation because that requires electromagnetism, and that is why I said that this will be covered after electromagnetism. So we can conclude that the speed of light is same in all frames of reference, and this is a mathematically derived fact. Okay, this was not mathematically derived, but taken to be true because of our intuition, right?
okay.
So now I'll show you that these two actually are compatible with each other. And if we believe that both Newtonian mechanics and Maxwell's laws are completely correct, then you end up with contradictions. Okay.
Can you try this drawing this in that doc file also having some draw?
Right. Right. I'm not sure if this has.
This
If there's
pen,
an option of a pen. Okay, no, it's
acha, highlighter. This is
the
highlighter.
highlighters. Hmm. I'm not sure if there's an option here.
Let me check. Sorry. Can you see the option insert and tools? These two options, can you click? Insert, what is there? Insert.
Image upload from the web.
Drawing. Yeah, insert drawing.
Right.
Check it. Now I think this will be a better one. You can draw it. You can select the pen and type and everything. I think
Like,
you can.
how do I start drawing? Okay, there are stuff for lines and arrows and stuff. Okay. Oh no, wait.
There was scribble also, I guess.
Uh, this is the select bar, right? How do I draw? Okay.
There are so many types of lines, so you can. These are the shapes.
I just need to make points.
Ah,
I
I
need to make.
think line you can click like 2 times and take at the starting point and end point maybe.
But this isn't coming out to be line. Okay, right. Okay. So let's say you have a person here. Person will be better as a circle, I think. Let's say you have a person here. You have another person here. Okay, wait. At the same starting point. Another person here, and you have a source of light here. Okay.
Okay.
And they are both coincident. Right? So ignore this vertical separation. We'll just say that they are on the same horizontal position right now. Okay. So let's say I need to give these names. Wait. Should I save? Can I use text? Like this would be better if I had a pen or something. This is actually quite slow. We can call this A, this person A. We can call this person B, and we can call this source of light L.
Okay.
Okay. So let's say B starts moving.
Okay.
I'll just write it out.
Hmm.
Okay, so okay, right. I see this. I see. The drawings come here. Can I not move this? Okay. So
Enter.
I'll just start writing here. I don't want these points to be. I don't want these indexes, but anyway.
Let it be there. No issue.
Suppose that starts moving. This is all.
Hmm.
A. Okay, so A is at rest. Suppose that B starts moving right at speed of C by 2, which is just 1.5 into whatever 10 raised to power 8 meters per second.
Yes.
And the light source emits a photon which is 3 into 10 raised to power 8
All of that.
right meters per second. So consider the situations after initially AB was 0 because they started at the same position.
Yes.
BL was also 0. No, let's not say BL. Let's say AL. AL was also 0. Right? So, will it be fine if I stop using this 10 raised to power 8 because it's tedious to write? Or I'll just say 1.5 and 3.
It is. We can take it as a granted notion.
All right. So, I'll
Or
just take C by 2
you can
1.5.
put S is equal to 10 to the power 8 and then use S as that.
Right. So, I'll just. Okay. So, I'll just say this is equal to
Somewhere you write it S or any name you can give.
1.5 times T. I'll just say one. No, not T. I'll say let's just say anything P. 1.5 times P. And this is
Put a comma and put
just
P
3
is
times
equal
P.
to this.
That's evident from the equation, right?
Okay.
So initially AB was 0 and AL was also 0. After 1 second, what will happen? After 1 second, AB will be, since B was moving at a speed of 1.5 p, after 1 second, AB will be 1.5 p. Like P is just the magnitude, ignore the units for now. It will be 1.5 into 10 raised to power 8 meters after 1 second. Right? And AL will be 3p.
3P, yes.
Okay. After 2 seconds, AB will be 3p and AL will be 6p.
Yes.
After 2 seconds, AB will be 4.5p and AL will be 9p. Right? Is there any confusion regarding it? I think this would be
No,
quite straightforward.
it is yes, simple.
So let's analyze the same situation from the frame of reference of B. Okay. So exact same situation. We're just considering the situation from the frame of reference of B. All right. So with respect to B, what will happen now? A moves to the left at speed 1.5 p. Wait, 1.5 p. Because with respect to A, B was moving to the right with 1.5 p. And from Maxwell's equations, we know that the speed of light is independent of inertial frame of reference chosen. So L will again move to the right at speed 3p. Is this fine?
Yes.
So let's now analyze from B's frame of reference. Initially, AB was 0 and AL is also 0. Right. These are magnitudes, these are not directions. So right, left, don't bother about that. After 1 second, AB will be 1.5p. This makes sense, right?
Yes.
But A is moving to the left now, with respect to B. All right, so there's no confusion regarding this, right?
If A is at starting point.
Right, at starting they were together. And BL is 3p. After 1 second. After 2 seconds, don't compare these to the results derived above, because then you'll obviously see a problem here, which I'll just point out. But
yeah.
right, after 2 seconds, AB will be P and BL will be 3. After 3 seconds, AB will be 4.5 P and BL will be 9. So this is the situation as seen from B's perspective, and this was the situation. Situation as seen from A's perspective, and this is the situation as seen from B's perspective. All right. So like, there's very obviously something wrong here, right? Because wait, as AB plus BL should be equal to AL, right? In friends, I'll just write them over here only. In the starting, okay, let's change this to BL. At the starting, AL was 0. It's just the sum of AB plus BL. AB plus BL is equal to AL, right? This is nothing fancy, right? Am I audible?
Yes, yes.
Right. After 1 second, this is 4.5p, and here it is 9p. Here it is 13.5. There's very obviously something wrong here, because if you see from B's point of view, at 1 second there seems to be in perfect synchronization. Nothing is wrong. AL is 0, and here also AL is 0 initially. After 1 second, in A's frame of reference, AL seems to be 3p, but in B's frame of reference, AL seems to be 4.5p. Like, so their results are starting to differ, right? After 2 seconds, AL seems to be from A's perspective 6p, while from B's perspective it seems to be 9p. So the difference is even more after pronounced after 2 seconds. And similarly, after 3 seconds, AL seems to be 9p from A's perspective, while it seems to be 13.5p from B's perspective. So, like, this is very obviously a contradiction. This is a contradiction. So, where did we go wrong? Right? We just used two theories from classical physics. We just used Newtonian mechanics and Maxwell's laws of electromagnetism, and both are very well established at the time, right? At the time when Einstein hadn't put forward his special theory of relativity, both were very well established. And just using those two, we have arrived at a contradiction, right? So there must obviously be something wrong, because like if you reach to a contradiction using some assumption, there must be something wrong in the initial assumptions, right? So let's check our assumptions. Our assumptions were the correctness of Newtonian mechanics and the correctness of Maxwell's laws. Right. So where do you think the problem can be? In Maxwell's laws or mechanics?
Okay. Uh, at present, we are not clear about these four laws of Maxwell, so we cannot tell definitely what may be the wrong, because
Right. That would make sense, but I just told you that these Maxwell's laws are mathematically rigorous. They have been tried and tested, and they are proved mathematically.
okay, okay,
All right. So I'll tell you the answer. The problem actually lies at Newtonian mechanics, because we didn't prove these. We took for granted that lengths and times don't change. That's why I was focusing on this for granted here, because we didn't prove, like Maxwell's laws are proved, right?
okay,
Uh, Mathematically rigorous, but no one has actually proved that a moving ruler is the same as a stationary ruler, or that a person in a moving car experiences time the same as a person standing on the road. Like, these are things we take for granted because they make sense,
okay,
but we haven't actually proved them, and it turns out these are not actually true. The problem lies with Newtonian mechanics. Lengths and times do change with the frame of reference.
okay,
So that was the problem we arrived at here, because uh, we said that the 1 second of A is equivalent to 1 second of B. That's why we arrived at these differing lengths. The inherent problem is with our measurements of time and our measurements of length, right? Like at first, many people would say that the Maxwell's laws seem to be incorrect, but these are actually more mathematically rigorous than mechanics is. And so that's why Einstein put his trust in Maxwell's law instead of mechanics. And it turns out he was right. Problem is with mechanics and unfounded assumption that times and lengths don't change, right?
no, this honestly speaking, that this time and length don't change with
Frame of reference.
frame of reference. Conceptualizing this point also is not that straightforward.
Yes, it's non-trivial, right? You're
It
correct.
is, it
And
is,
this is the main problem that people face when they study this topic, because they can't visualize that if a person if a it's like something is the length of a thing is changing when it starts moving, or that people experience time differently, and this is the main problem where comes to when people study relativity.
so my request now,
Right.
we will stop here.
Okay.
We will stop here,
Right.
and not that means further whatever you will describe, we will carry this confusion in next stage also. This frame of reference and time and length.
Okay.
This is not clear. You also agreed on that, and I am also agreed on that. So we should have more clarity on this, what we mean by frame of reference, time and length.
No,
And
length just means that length and
no,
time just mean
I am
whatever.
not. I am not. I don't want to get any explanation. Means there is an confusion. Take it granted. You can explain because you are thinking. You have studied long. This is, but it is not readily understandable. A common person will
Right,
not
right. That's
understand.
that's that's the point, right? This thing will go clear as you study. This will not be clear at first when you just introduce to it. This will become clear as you study it. Because what I was going to do next is I was actually going to prove how these times and length change.
Okay, okay. Then
Right.
we
I
can
wasn't going
continue.
to use these as facts to derive something else. I was going to actually describe how these times and length change
Okay,
just
okay,
from
okay,
using basic mathematics and geometry, nothing else.
okay, okay. Then you can go ahead. So
Right.
I was thinking of how we can get clarity on that. If you are
Right. So I was about to do that. I was not about to take these as facts, and I was going to
okay, okay,
prove something
okay. Then
else.
you can continue. Yes.
Right. Right. So if we are claiming something as bold as this, I mean, this obviously, like everyone rejected this when it was first proposed. If we are claiming something as bold as this, we should
Let
be
us have something. Muskan, are you there?
Yes, sir. Yes, sir.
Yeah, are you enjoying this discussion?
Yes, sir. Yes,
Honestly,
sir. I'm understanding. Yeah.
huh?
Yeah. I'm also understanding and listening to everything.
No, no, means even means if sometime you may feel that it is not relevant or something else, so and you may feel bored. So it is not compulsion that you have to present or listen properly or interact. Nothing. So if you feel that it is not that much important, you can leave what I mean to say. And if you feel that now we are getting a chance to get these things relook and re-understand properly, then you can continue. That was my point.
Sir, I didn't understand. Like,
But he's just saying that if you I have other work to do, you can leave the meeting. That's I think what he meant to say.
Yes, yes. So you
okay.
it is on you. It is not compulsion. Okay.
Right, because
Uh,
sir just asked me to describe this so that he could see what kind of content that I could provide, and it is
yes.
not I think related to what we will be going to do immediately right now in the next coming days.
Okay. So, like this meeting will be just like this
Like it's
lecture
just to
only.
get a gauge on the things that I can introduce to the content that sir can provide.
This will
Okay.
come definitely when we'll try to explain all these things in mathematical modeling, and then again poster making. We will make posters on these things also. Even we can write book also. So there, then it will be helpful if we have clarity on these topics
Yeah,
and
that's
every
why like I
topic.
was trying to listen. Like if
So you
like I
continue.
am along with
Yes, yes.
the lecture, then I'll get an idea about the flow and everything, and then I'll be able to like execute it properly. So
ठीक है. If you are interested and you are really enjoying, then continue. No issue. Okay,
yeah.
Aval, you can
Like,
continue.
I hope I'm not making this boring because
No, no,
I'm
no.
trying.
I am enjoying.
So
Yeah.
okay.
Because you see, we have tried many times to understand these things, but we fail to understand because these things, what is required, no, long time concentration and stepwise understanding.
Yes, yes.
So reaching, we can start A, B, C, D, E, F, and then we get lost, and we never reach it at Z.
Right.
So you already reached Z, so you can explain, and we, if we are interested, then we can learn also.
Right.
Yes. So I am trying to do that, and we will be making these things simple so that people really feel that yes, they have done
Hmm.
something.
Right, I feel I can do a much better job if I was given like 2 or 3 days intervals, which I could just plan out the whole lecture and plan out the whole content.
This is actually, you see, when we work together, no, what my motivation will be there. I am already committed 5,000 rupees. I will pay every month to you, and I am keeping aside around 20,000 for 4 month duration. We can continue after that also. So this is from my side. I have already mentally prepared for this. So 20,000, 20,000, 40,000 I have kept aside. But at the same time, I expect that there should be some substantial contribution also, some physical things,
Right.
and I should get good output in the form of whether it is poster or books or any form. So if it is that, then we both will gain in that way. And this is the one thing, when you explain to somebody, no, you will not find a person to explain also. So when you explain, it will increase your understanding.
Right.
So go ahead. No,
Sure. So I'll go ahead. Right. So as I said, if we're claiming that length and time change, if it is basically not at all intuitive, none of us think so. It is not ingrained into our common sense. So we should try to prove these. Right. So try to prove these. Now, Einstein yes, proposed postulates theory of relativity. So when Einstein was working on this, he used two postulates, which we'll just take as axioms. Right? I'm sure we know what an postulate is of special theory of relativity, and so as by definition these are axioms. So these won't be proved, but using these we'll prove everything else.
okay.
Right? First axiom is that all inertial frames of reference.
Inertial frame of reference, you mean to say that for if
Constant velocity, moving at constant velocity, not
or
accelerated.
will object is stationary, it will remain stationary, moving out there, it will go on way. This
Right.
you mean to
Right.
say?
Either stationary or moving at a constant speed, not
Yes,
accelerated. That's just what I mean.
yes, yes.
All inertial
So
frames of
no
reference.
external force will be working
Right.
on it.
Right. No acceleration. In the special theory of relativity does not deal with acceleration.
Okay.
Only constant speeds and rest. All inertial
These
frames
are
of
the critical points actually. When we study this thing, no, we miss it and we fail to understand it.
I'll just add there
Yes, yes.
for non-accelerated.
Hmm.
The two postulates are all inertial frames of reference are equivalent. This is the first. The second is speed of light is constant in frames of reference. Again, inertial frames of reference. Inertial frames of reference.
So when we talk about this light, speed of light is constant in inertial frame of reference, then we are not talking about medium
In vacuum. In vacuum.
in vacuum, or
In vacuum.
all we are talking in. Okay.
And is equal to C. So we'll just take everything to be in a vacuum. I'll just make that explicit now. And is equal. Which is what 299,792,458 meters per second. So okay. So these are the two postulates. So I don't think these are very complex. The second postulate is a little hard to wrap our heads around because we expect the speed of light to change with frames of reference, but it's a postulate, and using this postulate, we'll see that the contradictions that were arising before, they'll all be resolved, right? So the first one, I think it is pretty obvious. The second one is just a little bit harder to wrap our heads around, but as we'll see, this theory of relativity actually uh, makes all these contradictions go away. Okay, right. So using these postulates, actually do change. Okay, so if we consider, wait, where's the drawing? Case one. Let's do one case. A rod moving perpendicular. So we'll just consider a case here of a rod moving perpendicular to its length. All right. I'll just make a drawing here. Shapes. So this is our rod, and okay, so right, this is our rod for now. This is our rod. Let's say the rod will not make any assumptions about whether the length stays same or changes. We'll just prove everything mathematically from now on.
Okay.
We'll not make any assumption of the kind that the length stays same, and we'll see the results. We'll see the results that follow.
Okay.
Okay. So we'll not make the assumption that we were previously making, that lengths and times stay the same. We won't make that assumption. The length of the rod is L when it is at rest. Okay, so let's say the length of the rod is L when it is at rest. Okay.
Okay.
Now suppose that the rod starts moving constant speed. Okay. Suppose that the rod starts moving at a constant speed v towards the right, and let the length of the rod in this case be L dash. L dash can be equal to L, L dash can be not equal to L. We're just saying it's L dash, right? We're not making any assumption whether
Okay.
L dash is equal to L or not equal to L.
Okay.
Let the length of the rod in this case be L dash. Right. So there are only three possibilities. There are only three possibilities. One, L dash is greater than L. Second, L dash is less than L. Third, L dash is equal to L. Is this fine? I mean, there cannot be anything else than this, right? Only three possibilities are there. So that L dash is actually equal to L in this case. We will show that in this case, what we thought was common sense is actually true. In this case, the length won't change. All right.
Yes.
We are going to prove this now. And the proof will be proof by contradiction. So I'm sure you are familiar with proofs by contradiction.
Yes.
Right. So let's sake of contradiction. L dash is greater than L. For the sake of contradiction, we'll assume this, and then we'll show that this can be possible. Is this fine?
Yes.
For the sake of contradiction, we'll say that L dash is greater than L. Assume two identical rods at, I'll make the diagram right now so it's not confusing. Both of length L. Okay. So this is the first rod, and
Right click again and paste. You can do it.
okay, we can do that. Right. Paste. I want these to be aligned. Okay. These are two rods. Both of these are identical when they are at rest. Okay. Now let the left rod start moving at speed v to the right. Its length will be L dash now, while the length of the right rod will still be L as it is at.
Yes.
Okay. Wait, I need to edit this. How do I edit a drawing? But copy paste for formatting. Edit image options, all text. I'll just make a new one. I'll just make a new one. That's not a problem.
Okay, got it.
Since we are assuming the assuming that L dash is greater than L. So now, since we are assuming that L dash is greater than L, the left rod will be slightly larger, right? The rod which is moving will be slightly larger. So is this fine?
Yes.
I need to add some color. Can I add some color?
I think you can right click on that object,
Right.
and then I think you can edit text or
I don't think there's an option.
change shape. Change shape. In change shape. What are the options? Shape.
Only
position.
shapes. Only shapes. Okay, sir. I'll just write. Let's say the ends of this wait, end of wait, end of this left rod was blue, painted with blue. Wait, can this not be in one line? I think.
It can be. You can drag right side. This corner
Right,
point
right.
you can drag. Now you can write.
Blue. Okay. Right. So this was painted blue. This
Yes.
topmost edge of this, and this the rod which is not moving was painted red, and this paint is wet. Okay. this paint is wet. This was not actually done after they started moving. This was done here also. I've just not shown it. This is painted blue. This end is painted blue, and this end is painted red.
Okay.
Okay. So now that when wait, drawing hasn't been attempted. Okay, it has. So now that when the left rod starts moving to the right, and L dash is greater than L, we are assuming that for the sake of contradiction. This end is painted blue, this end is painted red, and this paint is wet. Okay, so this is just a normal situation. The paints are wet. Now, as the left rod passes over the right rod, what will we expect? As the ends were painted and the paint was wet, when this larger rod moves with the smaller rod, we'll expect that some of the red paint here will get over the rod here, right?
Yes.
Right. So this is a valid reasoning. This is valid reasoning. We will expect that the left rod, I'll just highlight this. Left rod will be colored red just below its top end. All right, we expect this to happen. Now, since all inertial frames and the rod was moving at a constant speed, so this is an inertial frame, right? Are equivalent, which is just postulate one. Postulate one. We can analyze from frame of reference of the rod, and we should end up with the same result. So is this fine?
Since
All inertial frames are equivalent, which was postulate one of relativity, we can analyze the same situation, exact same situation from the frame of reference of the left rod, and we should end up with the same result. And the result is that wait. And the result is that the left rod will be colored red just below its top end, around here.
yes,
Right?
this is one case. Yes.
Right. So from frame of reference of the left rod, right rod is moving to the left at speed v, and the left rod itself is stationary. Is this fine?
Yes.
Hello? Right.
Yes.
And since we have assumed the length of the rod increases when it moves, we can say that in this way, length of the left rod is L, while of the right rod is L dash. This is also fine.
Yes.
Right. So now let's make another diagram from the frame of reference of the left rod. Shape. This is the left rod, and this is the right rod, as seen from the left rod's frame of reference.
Okay.
And this was blue, right? Just
Yes.
blue. I think you'll be able to figure out what I'm going to do now. This was red.
Yes.
And the right rod is moving towards the left. Now, the right rod passes over the left rod. Left rod will not be colored red as L dash was greater than L. Does this seem obvious?
Yeah.
Right? So because the paint is above the length of the left rod.
But now red rod get painted
Yes.
with
Yes. The red rod will be painted with blue. That's completely fine. But we're just focusing on the left rod for now. All right.
okay.
So the same situation when we were analyzing from the right rod's frame of reference, we saw that the left rod was colored, right? But when we are analyzing the same situation from the left rod's frame, we're seeing that the left rod is not colored now, right?
Yes.
This is a contradiction. So our assumption must be wrong. And what was our assumption? It was that L dash is greater than L, right? We conclude that L dash can't be greater than L. Is this fine? Uh, is this fine? Or do I need to go over this once again?
No, it is okay. Up to this, okay. And it is up to this. It is you can say it is a common sense sort of thing.
Right. Till now, it's common sense. It's completely common sense. Relativity is mostly common sense. It's just if you take the two postulates to be true, then everything that follows is common sense.
Okay.
So we conclude that L dash can't be greater than L. Similarly,
it can
it
be
can't be
smaller
smaller than right.
Yes.
Exactly. L dash can't be smaller than L. The only option is that L dash equal to L, right?
So indirectly, we can say any object, whether by moving, you cannot reduce it dimension.
No, right. Not exactly. We
Okay.
took the motion was perpendicular to its length, right? We haven't considered the case in which the rod is moving parallel to its length, like vertically. We just said the rod is vertical and it is moving horizontally. In this case, its length won't change.
Okay.
Right? We'll actually see that when it moves parallel to its length, it does change. It does change
Okay.
in that case. But in this case, our intuition holds and the length doesn't change.
Okay.
And we just proved this using contradiction. We did not make any assumptions. We have proved this mathematically.
Yes.
Right. This was case 1. Now let's see case 2. Case 2 is not related to length, it's related to time. And changes that happen to time when we change your reference. Okay. So we have a simple clock that works. I'll now describe how what this clock is and how it works. Shape. So consider this very thin rod, and it has two mirrors at its ends.
Okay,
Line.
okay.
Wait. Can I not make lines? There was an option. Okay, I can. This is actually at its end. Uh, I hope that it's clear. These are two mirrors, one at this end and one at this end.
Okay.
And the lower end acts as a mirror. And the lower end also has a, wait, no, both of these are mirrors. And the lower end keeps time. I'll describe how it keeps time.
So it is having a mirror as well as a timer.
Right, you can say that. Lower end keeps time, and there are mirrors at both ends. All right. We'll see actually that the lower end needs to keep time, and only the mirror is required at the top end. So if you so if you don't even consider the mirror at the lower end, that's fine. You just need a mirror here and something that keeps time here. Save and close.
So first tell me, when you learned this theory, how you learned it?
Sir, I actually just learned it out of interest after in my 12th class when I was in 12th. So
Because this type of learning never happens in classroom.
right. This isn't taught in 12th class. This isn't even taught in college, except to people uh, who are majoring in physics. I'm not majoring in physics. I'm majoring in computer science. So I just learned this out of interest when I was in 12th class.
Very good. Very good.
So
And that's why you are able to explain so nicely, because when you learn it as a course material,
right. So
you
that
learn the theories and memorize that formulas and material there. That clarity you will never get on that.
Right.
Okay, go ahead.
Sure.
And now we will make it whatever drawing and design you are doing. We will do it in either MATLAB or Excel, and real sense we can model and show that this happens.
Right.
Okay.
Right. The lower end of the rod, length L. The length of the rod is L. This vertical length is L. Time. Mirror. Okay. So let me just describe how it keeps time. There is a light source and it releases photons, and whenever photon reaches the other end of the rod, is reflected the mirror and comes back to the end. The clock ticks. Okay.
Let me understand this. Actually, there is a so that clock keeps on tracking that photon when this
The
reflected
clock ticks because of the photon. The clock ticks because of the photon. So in our daily daily life, we have wall clocks and etc. They all tick due to some mechanism going inside them, right? Because they can't tick by themselves. Like the people designing the clocks have to make some sort of mechanism that causes them to tick, right? The internal mechanism. So this is one kind of mechanism that can be possible. There can be many types of mechanisms. This is just one type of mechanism, right?
Yes.
So this is just the mechanism of how the clock ticks. Whenever it sends out photons, whenever it receives photon after reflection, it takes 1 unit, right? So this is fine, right? I can clarify if you have any doubts.
No, it is okay. After this, okay.
Right. Okay. So if the rod is at rest,
Actually, I was trying to model one clock, and then I was thinking what is time, what is a minute, and etc. All these things. So in one way, there is nothing called time. Time cannot be measured. Actually, we measure in clock. What we measure is angle. Angle we convert into
right,
time.
right.
So
That's one thing to think about it, right? Actually, time is very it's a very topic of research in physics also. So we're not going to that. We'll just say that when the clock ticks, it takes 1 unit, 1 unit of time passes. We'll just keep it simple, right?
yes.
We'll not go into the deeper because I don't have knowledge about that, so I can't comment. Let's say that at t equal to 0, uh, one photon is emitted along the rod. All right, so this happens at t equal to 0. A photon is emitted from here. It travels. It is going to travel along the rod, hit the mirror, get reflected, and come back. And at that point of time, the clock will take 1 unit.
Correct.
Right. So it will take time, and also consider that the rod is at rest. It will take time L divided by
No,
C.
it will. This same thing is applicable when it is moving also.
Right, just with a slight difference, which I'll show you.
Okay, 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 okay.
So it will take time L by C to move to reach us. To reach will be a better wording. To reach the mirror.
Hmm.
Is this obvious?
Hmm.
And it will take another L by C units of time to get back. Right. So we can say that the first clock tick happens at t equals to L by C plus L by C, which is nothing but 2L by C.
Hmm.
So everything is fine up till now.
Yes.
Uh, this was the case in which the rod is at rest. In this case, the first clock tick happens at t equal to 2L by C. This is fine. There's nothing really complicated happening here. If now we'll consider another case. If the rod is moving at speed v, direction doesn't actually matter.
So
It can be to
relative
the
velocity factor will come here.
right. Here the velocity factor will come.
Two velocity is moving, light velocity and itself rod velocity.
Right. So here's the V will play a role here. Right.
Yes,
So
yes.
you can already foresee that, right?
Okay.
Uh,
And that makes thing complex to visualize what will happen.
Right, right. So that's why I need drawings, and it
Because
will be
many
better you described using animations and modeling. You're right.
because many times when we move in train, no train is moving, and
Hmm.
suppose I am also moving with the compartment. I am walking from one point to other point. So train is moving, and I am also moving. So
Right,
what will be the relative things? Very
right,
it appears to be very complex.
right.
Yes, yes, okay.
And
Go
that's where
ahead.
the name relativity comes from relative motion.
Yes, yes.
So if the rod is moving at a speed v to the right, uh, we just proved above that the length of the rod change in this case. We have proved this. We have proved this above that if the rod is moving perpendicular to its length won't change. It will stay L. We were going to use this now. That's why I proved that earlier. Otherwise, we could not have assumed due to common sense that the length will remain the same. We had to prove this. We are going to prove everything. We're not taking anything for granted here.
No, that means you are taking that rod will remain same length.
Same length,
It
right?
will not change.
Right. We are using
And
the
we are
result of
not
this.
going to this thing what we have proved earlier.
Hmm.
It will also true for this situation also.
Right. Because in this case also the rod is moving perpendicular to its length to the right. So we can say it using the result above that the length won't change.
Acha, here also you are moving not vertically.
Not vertically, only to the right.
Okay, okay, okay.
I
So
should make that
same movements means earlier also it was moving horizontally. Now also it is moving
right,
horizontally.
exactly,
Only
exactly.
thing it is having some time
Some timer
between
and a mirror.
mirror. Okay, 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 good.
Right. I will make that explicit. I should make that. Moving speed to the right with no motion parallel to its length. So I think that should be better. Length of the rod won't change in this case. If it was moving parallel to its length, we could not have said anything because we haven't seen that situation yet. We haven't proved anything for that yet, right?
Yes.
But because we have proved for perpendicular motion that the length doesn't change, we can use that.
Okay. Okay.
We just proved that the length of the rod won't change in this case, right? So let's see when the first click happen now. I'll make a photo. Wait, what? Acha.
This way of presentation is good. You see, this speed is also there, and you have all the tools, writing tools, and
Right, that would have taken way too long.
yeah.
So this is your rod. I need to make lines.
Actually, this is the reason I work on these things. Now, technology has made our life so simple, and we are not using that advantage in teaching, learning, is not it?
Right, you're right. Like
Because
actually,
you see, in my time, I could not even imagine this can be done like so easily. Uh, and physically fasting we require to present physically, which is not again possible.
mm,
Now you
mm.
are sitting here, where you are explaining
I live in Chandigarh.
Chandigarh. I am in Ahmedabad, and we are not feeling
Mm,
that we are that far away. Is not
right,
it? So all these
right.
advantages are there, and we are using. People are trying to cope up. So my book is on teaching mathematics in 21st century. So
Okay.
why we stress on 21st century means this century is entirely different than other centuries. So it is a technology driven time, and we should use technology for teaching and learning mathematics. That is the main point I want to spread actually. And
Right.
then school is secondary.
Hmm.
People should still many college professors, they are still using that slide presentation, or they are not using anything, they are only writing in boards. They are not using not a single technology. They are in old fashion, they are teaching
Yes.
like that. So very good. Okay, go ahead.
So there's one thing I think that is most college professors they don't want to teach. They just want to do their own things, and they consider teaching to be their secondary job. I think.
And it is not only for professor themselves. The administration also think that they are overloaded with some means tertiary jobs. No, not secondary even. They forget their primary job is teaching.
Right.
They are overloaded with administrative work, this procedural work, formalities, all these things. And in addition to that, they have to meet this accounting, auditing, IT return filing, movable, immovable property declaration. A lot of time we are required to spend for all those things. Then how they can concentrate on their primary object of teaching. So all these things are there, but still we have to go with them. We cannot. Okay, go ahead.
Yes. Okay. So this will be when the photon is released.
Yes.
Photon is released. Now, when the photon actually reaches the mirror, the rod will have moved a little bit to the right because it is
Yes.
moving. So let's just draw that out as well. Wait.
I'm not sure whether I can able to do it or not in my modeling skill. But if I can do it, I feel that will be a great achievement for me to explain relativity in Excel. Excel, why I am stressing because as you are drawing without any stress, no, in Excel you can do it in numbers.
Okay.
Here you are drawing, there you will use numbers for all these things, whatever
Okay.
you are doing here.
Just pardon these lines because they are not really accurate, but I think you
Okay,
can
okay.
understand.
Yes, yes.
Photon reaches.
Or you can do that, you can make a group of these three things. No, you have drawn earlier, and no, left one.
Right. I could have copied. Yes.
Okay, go ahead. No.
Photon reaches mirror. And final one, I'll just copy this.
You have to select all these three. Means your mirror, and then right click.
I can only select one at a time.
Shift. You can press the shift and then press
Okay.
shift button,
Yes.
and then
Uh,
yeah, and bottom one also. And there is an option for group. I think right click on that. Right click.
where right click here?
In mouse right click.
Okay.
Yes, something group. No, not copy. Okay, try it copy.
I tried copying.
Paste, right click, paste. Now drag it. It is copied. You can select and drag now. No, it is let it be. Now you select it and drag.
Right.
Yes.
And I'll just say
Easy.
photon reaches back to the rod.
Yes.
Right. So the
Yes.
photon will have to move something along this path, and then after deflection, it will move like here. So is that visualizable? Like you can visualize that?
I can visualize that, but um, you mean to say it has to travel longer path?
Right. Right. Exactly.
So the more the speed increases, it has to travel more longer distances.
We'll derive that. We'll derive that. We'll derive that.
Okay.
We'll
Yes, I
derive
got.
everything. We'll derive
Uh,
everything.
we got it. Yes.
Right. So I'll just make the path of the photon as well for clarity. I'm not able to wait. Okay. It has to move along this, and then it has to move along this. Right. So it would be better if I could have made an arrow.
Arrow also you have the option. No,
But these won't be
no,
diagonal now.
not. You need not go there. In line itself, there is an option for editing.
Okay. Wait, I'll just do that. I'll use an arrow.
That I tell that now life is so simple. Knowledge is in your control. Means we are moving with knowledge bank, you can say. Everything you can just give a search, you will get. And technology also, you can do a lot of things easily.
Right.
Even that copy paste was harder 10 years back also. It was not that easy now.
So just one thing that is this obvious that the time taken for the photon to go from here to here is the same as going from here to here? Because the speed of the rod is constant.
Speed is, if it is speed is same, it will be same.
Speed is same. So I'll just prove half the time for here, and the same will be the time from here. Right? Okay. So I'll save this. Okay. Right. So consider time of on, and let us call the time of travel here t dash because it was t in the first case. Did I say that? I'll change this to capital T.
Okay.
And here it will be t dash, capital T dash.
Okay.
So the time by the photon reach the topmost point of the capital T dash divided by 2. Right? So now let's find out. I'll just call this small t. Let be capital T dash divided by 2. The horizontal distance moved by the rod in this time is Vt. The hypotenuse.
Now I can understand that importance of that why there should
Velocity.
not be any acceleration.
Right. The acceleration would have just complicated things a whole lot.
Yes.
And the hypotenuse. Can you see the hypotenuse? What I'm calling the hypotenuse? I'm calling this the hypotenuse.
L square plus this distance square.
Which is the
Square root of that.
distance traveled by the photon
Is equal to square
CT.
root of that.
No, it's just CT, right? Hypotenuse, length of the hypotenuse, because the photon travels along this. The speed of the photon is c.
Okay.
Right?
Yes.
So this does this need further clarification, or is this okay?
This is okay.
This is CT
Because
and
we are
this is VT.
thinking that it has reached their time t,
Right.
small t.
Right.
So
Exactly.
it is velocity is again same.
Exactly.
And,
Exactly.
okay.
Exactly. We're using that fact that the velocity is same. Velocity is seen in every frame. We're using that fact.
Yes.
I'll just make it clear. The fact I should say speed. Velocity, speed of thing. Right. Using the Pythagorean theorem, like you just said yesterday, the most famous theorem.
Yes. We cannot escape without that.
Right. We can say, and we also knew that this length was L because it will not change. This is L, the height is L, the base is BT, the hypotenuse is CT. We can say CT square is equal to VT square plus
It is not moving
L
at
square.
the speed of light. It is moving at its own speed.
The rod is moving at its own speed, the photon is moving at the speed of light.
Okay. Okay.
So is this equation fine?
Yes, it is okay.
So let's simplify this. It would have been better if we could have used LaTeX. Do we have the provision to use LaTeX in this document?
Latex I have I share with I have shared, I think.
You've shared the overleaf ID. Yes.
Overleaf.
If it's fine, I can do it. I can do it. It's
So-
not that complicated.
So what we can do in latex, we can draw all those things directly as we are thinking.
Right.
But anyhow, let us learn first the concept, then
Right.
we'll decide everything.
Right.
Even
Let's do
we
that.
can take it from here to latex also.
Sure. I can do that. So L square is what? It's C square minus B square times T square. Wait, T square. And we can calculate for T. This implies T is capital L divided by square root of C square minus V square.
Yes.
Right? And T was T dash by 2, right?
Yes.
This implies T dash equal to 2L divided by square root of C square minus V square. Is this correct?
Yes.
So this frame of reference, the first clock tick happens at T dash, which is not equal to T. Right? I'll just show the expression for T. Right. When the rod wasn't moving, the first clock tick happened at T is equal to 2L by C. When the rod is moving, the first clock tick happens at T dash equal to 2L divided by square root of C square minus V square.
Yes.
Right. And can you guess which one is bigger?
This definitely T dash will be bigger. What I should say.
Right. So we can see that T dash is, and from here, we can see that T dash is bigger than T. Right. So some important implications of this fact. In real life, the velocities that we deal with, velocities of moving cars, moving trains, they're all very small as compared to the speed of light.
Yes,
You agree
yes.
with me? Right. So in practical life, this v square term is actually negligible.
Yes.
Right. So if we neglect this term, this will t dash will be 2l by c only if we just neglect this v square term. Right. So and 2l by c was nothing but t here, 2l by c. So in the expression for d dash, if we just neglect the speed of light as being very small as compared to the speed of motion as being very small as compared to the speed of light, we can say in practical life, t dash is almost equal to. Is that correct? So this is why we don't observe the significant differences in real life when someone is traveling on a car and someone is just standing on the road at rest. They don't see that one person 1 hour has passed and for the other person 2 hours have passed. That sort of thing doesn't happen because the speed of the motion is very small as compared to the speed of light. Right?
I'm getting the point you are trying to explain. That's why I think we are not facing any problem with Newtonian theories. But
Right.
if
That's
we
fine.
go,
That's fine. That's fine. That's fine. If we had like cars moving at half the speed of light, then there would have been significant differences.
yes,
But as of now, like nothing exists that can move that fast. So that's why we don't face any problems using classical mechanics.
yes, okay, okay, continue and
And also one point I'll just make it clear. Here also in the contradiction that I showed, B was moving at half the speed of light.
mm,
So this is comparable to the speed of light. This is not negligible, right?
yes.
And that is why the whole contradiction happened in the first place.
But even if you think of that is very considerable speed, is that contradiction be removed there? AL and BL? No.
What? I don't get your point.
It is contradiction. If you tell that this is due to the velocity of the object, when it was substantial, that's why it is creating contradiction. But is that if we take it is speed is very small, then
Right.
can
So
we remove the contradiction? I don't feel so.
right. So the contradiction just happened because we were seeing differences in the AL, right? In AL.
Okay, okay. This also now it is not a
When the
time to go details on that because all are intuitively still. And if we model and we see the effect, and then we can talk. We will go for another session for all these things because
I
now
just point this out. It's very small. That if B is not traveling at a speed comparable to the speed of light, this AB will be very small as compared to BL and AL.
okay.
Right. So if you just neglect AB, you just get BL is equal to AL. So that
Okay, okay,
right.
okay. In that
So
way, it can be contradiction can be removed.
right, right. If
Okay,
B is traveling at a speed very less than speed of light.
okay, okay, okay.
And as the first clock tick in the moving frame of.
So again, another point I should. I am thinking of that. That means when we are triggering the photon, that means our photon is moving in all the circular direction.
Right, right, right.
And it is not that I am triggering it in vertical direction and it is
No, no,
coming
no,
back.
no, no, no. You're correct. You're correct.
We are circular way. We are triggering this photon, and when it is hitting there, then particular one photon which is moved in that
Exactly, exactly.
angle, that only hitting. And we
Exactly,
are
exactly.
concerned about that photon only. Rest
Right.
of the photon we are not considering.
They won't be reflected anywhere because they won't hit the end of the rod.
Okay, okay.
And as the first,
Very nicely explained. Yes.
thank you, sir. And as the first clock tick in the moving frame of reference happens later than the uh, stationary frame of reference. Say that this is the result, which is very famous in relativity. I'll just make it bold. Moving clocks tick slower.
What is it? And
Like the tick happened later in the moving frame, right? T dash was greater than T. You can assume that there is a clock that ticked from 12 to 1. Let's just say that's a very long tick, but for the sake of convenience, say it ticks from 12 to 1. So it ticked earlier in the stationary frame, but when it was moving, it took a longer time to tick.
It I guess it means like time passes slowly as like we approach the speed of light, right?
Right.
Okay.
That's exactly what it means. Like, is this mathematically clear? Right? It won't be intuitively clear because we are not used to this, but we just proved this, right?
Yeah, yeah, yeah. Like the math is clear.
Like, T dash is greater than T. So this effect is called time dilation. Because time is sort of being dilated, is being spread out when things are moving. Moving clocks tick slower. Another point. The ratio T dash divided by T. This is what? This is C divided by square root of C square minus
Like
B square.
inverse, its square root should be no. Yeah, you're correct.
I think it's correct. So is this fine? T dash divided by T is C by square root of C square minus V square.
okay.
Right? And I'm just writing this in another format. This is 1 divided by square root of 1 minus V square divided by C square. Right?
Yes.
The only reason I'm writing this is the Lorentz factor. This is a very important term in relativity. This is important term in Lorentz factor.
T is there.
Like LORENTZ, Lorentz. Important factor in relativity. This is called the Lorentz factor. And it is denoted by gamma. Can I use gamma somewhere? Greek alphabet. I don't think so.
Insert symbol somewhere will be there, but where it is, insert symbols.
All right, special characters here. They should be gamma. Okay, wait. Greek. All right, so I'll just say it's G instead of gamma.
Okay.
G, which is the Lorentz factor.
So B by C, yes.
1 by square root of 1 minus V square by C square. This is G.
Okay.
And G is greater than 1, as is obvious, because the denominator is less than 1. The Lorentz factor is always greater than 1. So, moving clocks run slow by a factor of G.
Yes.
G depends on speed of motion. G is not a constant, G depends on the speed of motion because it is dependent on V. Right. So I just have one last effect.
It depends on speed of motion in the sense what you mean with.
Speed of motion of the clock. The clock. If the clock is moving at v, then you can see that the g changes with v, right? If we change v, then we change g,
Yes, yes.
right? If we increase v, then g also increases, right? So the factor by which the clock runs slow depends on the speed of motion. So if say a clock is running at 5 meters per second, it will run slightly slower than a clock at rest. And if a clock is moving at 10 meters per second, if it moves slightly, it would move even slower than the clock moving at 5 meters per second. But the difference is not actually visible in real life because 5 meters per second is negligible as compared to c. But anyway, if you calculate exactly, then there will be a difference. So now we have the last case.
Sorry to interrupt. Our sir, like I have to leave at around 10.
Right.
Yeah.
Okay,
So
no issue. You can move go, and we'll discuss again tomorrow. This time 8 o'clock around. And meanwhile, we will be in touch with that WhatsApp and other
Right.
notes.
Right.
okay, sir. And any specific work for tomorrow? Like anything I have to prepare for tomorrow?
We'll discuss. Have you seen that Google Classroom?
No,
You
I didn't see. I thought it was for the animation, but I did that, so that's why I thought I shouldn't do it.
animation you got how to do?
Yeah, I was reading. Like I tried one example from the internet, but I'm
That
still like
you
looking through the
try
videos.
actually what happens in PDF you can create that animation similar way we play the movies and window interface
Yeah, like
similar thing
stage.
you can
Yes, sir.
so you try that one next. Okay.
Yeah, and like, is there some material on the Google Classroom?
Google Classroom, actually, you can join that Google Classroom, then you will understand what was there are already 75 people joined in my Google Classroom, and there was much interaction. Whether we can move for our group, no, whether it is suitable for moving in that, whether we can add it to our website. Uh, so that people who joins they can directly interact in Google Classroom. This effectiveness, the primary thing you do, and rest will we have not said yet. Again, what to be done in main focus will be on creating posters. So 1-2 days we will be taking for interaction with each other, and then we'll start developing those posters. That is the primary means objective for us. We should at least create 100 posters in different subject in a month. Initially it will be a slower thing, but once we set our uh, templates formats, then we can go on adding very fast. So this is the main objective, and all these things we will be doing, and whatever the posters we will create, that will be created in this PDF, no? And in PDF, what we create in latex, there we can use that beamer, and in beamer we can use that animation. So we can animate any this type of thing also. We can make poster, and that poster can itself be animated when they open it
Okay,
in.
sir.
So this is the broad thing what I have thought till date. And 1-2 days we discuss, and you explore the possibilities of PDF and animation. Then we can finalize those things, and we will move ahead.
Okay, sir. Okay.
So just one thing. Can we keep tomorrow's meeting a bit short because I have a test day after?
No issue. This all depends on you see your career and your exam is primary means focus for you, and that should be given priority, and this is a secondary thing. uh, uh, so anytime it conflicts comes, so you get a priority on your objective. Okay, so I am very much flexible, but at the same time, when you get time, then you spend more time.
Yes, yes,
Like that, we
yes,
can compensate and each one.
yes, yes,
And these are the way we can learn each other,
yes, right.
and we can learn lot of things. Individually, learning is very slow process. Discussing
Yes,
and
sir.
one story I should say. In West Bengal, there is a culture of clubs. You know that everywhere it is there, but we in the young age we used to gather in clubs, and we used to discuss almost everything, and the knowledge we gain from that, no, because I read something, he reads something, he reads something, and we come together and discuss, and in friendly mood we learn so many things. Even I benefited in interviews, because some question came which I was means one of my friends was discussing with me 3 4 months back, some topics, and the same question was asked in the interview board, and
Okay,
as I had a discussion with him, I was knowing that this will be the answer, so that will benefit. So in that way I am telling, when we discuss it, then we learn more. So we'll go in that mode. Okay.
right.
Yes, sir.
Sure.
So
So,
we are continuing, and
should we?
whenever you feel you can go, no problem for that. Okay. And we had a rule also. Anyhow, I'll not tell that today. We'll discuss it later. Okay, go. Right.
Okay, sir. Thank you.
Okay. Bye.
So, should I conclude, sir?
Yes. Yes. Oh, well, you can
Okay.
continue.
So, is this saved automatically?
Yeah, it saved automatically.
Right.
That
So I
is the
can close
advantage
this.
of Google Docs, Google Slide, Google anything you do it, and it can work in shared mode. So next time you can open in your mail and you can edit it, you can change it. I can see whatever has been done.
Right. So I can close this without any saving, right? Sure.
Nothing will happen because everything you are doing in cloud.
Right. Okay. So I'll stop sharing now. So I hope that was understandable.
So
I
you
tried.
finished your presentation.
Right.
Okay, okay. Then this is the thing, and I will try to model it, and if you
There
want
are some. There are a few more topics, but we can cover them.
next time, okay. And this Newtonian theories, whatever you are talking, and we have made a app in MATLAB, and you can see that in that we can get a velocity acceleration of any type of motion. We can give that formulas, and we can get it automatically. It creates. And Maxwell formulas. Next time you explain that what are the four Maxwell
Okay.
formulas.
They're not really much to explain. They're like mostly mathematical, and they require a bit of vector calculus,
You just
gradient and curl.
mention it.
So,
You just mention this is a 1, 2, 3, 4, and like that.
so
And
but before that, I'll have to introduce electric field and magnetic field. So,
whatever you want, you can make a
sure,
formal things.
sure. So, can I explain this on maybe Sunday because tomorrow, Saturday, I have a test.
Yes,
So,
yes. No issue. Tomorrow is Sunday.
tomorrow is Friday. Tomorrow is Friday.
Friday. So
Right.
you
So,
want
day
it?
after I have a test. Day after I have a test.
Okay. So any Sunday okay, wanted that? No
Right.
problem.
I can also do on Saturday evening.
Saturday will be fine if you can, and like that things, and that one poster I have sent. In that poster I have sent how to modeling and animation.
Okay, I'll see that. I'll see that.
And here, there I have given three tools which you require to learn,
Okay.
and where you can learn three tools in Excel, three tools in MATLAB. You try
Okay.
to learn yourself and tell me, yes, sir, it is okay. If you
Right.
cannot
Right.
learn yourself, then we have to improve that poster.
Sure. Sure. Okay. Okay, I'll do that.
So this will be a litmus test whether it is okay or not.
So,
And this
I'll do this by Saturday evening. This what poster thing.
anytime. This
Right.
whenever you find time, you can do that. No problem.
Right.
Okay. So tomorrow are we meeting?
We can meet. But I would prefer if it is short, like at max 1 hour, because I need to study.
Okay.
We
One
can
hour
meet.
we will meet. 8 to 9.
Right. Right.
Okay. So bye now. Okay.
Thank you, sir. I hope the presentation was understandable and I didn't confuse that.
Very nice. Actually, this we never reach up to this last level.
Hmm.
We start and we stop in between. But that last phase, and even if you have that rod remains same, L
Hmm.
remains same, that even we can assume and explain.
Hmm.
That is not very much important for, because we know that if any rod, metallic rod, without any huge force, it never gets deformed. Always
But
sometimes.
I proved that because at the case 3, which I'll discuss later, in that case we will see that the length actually changes when the
Okay.
motion is parallel to the length of the rod.
So we have to be last part. It is not complete. Last part.
Right. There's just
Okay.
there are just two things left. There are two things left.
Okay. Okay. So next time we will discuss that also.
Sure. Sure.
Okay then. So bye for today. Okay.
Right.
And we will be going informally, though I will be putting a selection later and all those things, but we should be a mostly friendly relationship, and then only we can interact, because our age difference is huge, but we should not that should not make us different. Okay,
Right.
you think of at your age, and I will also treat myself as at your age, and we'll discuss and learn. Okay.
Okay, sir.
Okay. Bye.
Thank you, sir.